Hey guys, in this video we're going to be talking about the computation of the area between curves. So on the prior Edpuzzle video, there was an illustration of how this works. A general formula was given, looks like this, the integral from a to b of f of x minus g of x dx. So we illustrated how no matter where these curves are in relation to the x-axis, whether they're both above, whether they're both below, whether one's above and one's below, this works out to give us the area. And in simpler terms, if you want to think of this sort of as our first function, I like to refer to that as our top function, and then the other function sort of as the bottom function. So really you just think of it as the integral of the top minus the bottom. That's how I look at it. Now the only other part that wasn't really covered that thoroughly in the video was where these a's and b's come from, right? So the a's and the b's, those are actually the points of intersection. So in this particular example, you can see the two places where they intersect, where we were trying to find this region R, right? The limits, and you might want to make note of this, the limits are places where the curves, and actually, let me be a little bit more specific, not the places, but they are the x values. The x values where the functions intersect. Very important note there. That's how we come up with the a's and the b's. They're x values where the functions intersect. So not y values, they're x values. Right, and the f of x corresponds to the top function, if you will. So in this particular example, our top function is the one here, all right, that orange one, and that's represented by the first function here, f of x. You shouldn't necessarily always assume that that's going to be the case. The first one would be the top. I think that is the case with these delta maths, but don't always assume that. We do know that that is a upside down parabola, if you will, a negative x squared function, so that is going to be our f of x. And then the bottom function in this case is our g of x, which is this straight line here. It's just a linear function. So to find the area between those, we're going to do f of x minus g of x over the interval from 0, because 0 is where the x value where they intersect here, to 3, because 3 is the, look up the x value there. Right? So we can set up our function. It will look like this. The integral from 0 to 3 of f of x, that's negative x squared plus x, minus our g of x. I always put that in parentheses, whether it's a negative in front of there or not, because sometimes it'll be multiple terms. So it's always good to put the second function entirely in parentheses, because you're going to have to distribute a negative symbol at times. All right, so here's our setup. Now to just make this a little bit more compact, let's go ahead and combine some like terms before we integrate this. So the integral from 0 to 3 of negative x squared, that becomes a plus 2x. So this overall will be a plus 3x dx. So this is our setup. It's all good. Now from here, we're going to use the fundamental theorem of calculus, part 2, if you will, to integrate this, plug in the top limit minus the bottom limit. I'm going to just delete this purple here. So if you need to write that down, go ahead. All right. So let's go ahead and integrate this. Notice also you'll see these are non-calculator questions, meaning on the AP test, this would be in the non-calculator section, which there is a non-calculator multiple choice and a calculator multiple choice. There is also a non-calculator free response and a calculator free response. So you need to know how to do this without a calculator. I will show you some problems probably in the next assignment where you're going to be using a calculator to do this, but these are all questions which you should be able to solve without a calculator. So practice doing it without a calculator. By all means, if you want to check your answer afterwards using a calculator, do so, but try to do this fully without a calculator at least the first time. All right, maybe since you have 2 attempts, you could do without a calculator. If you get it wrong, go through and check it with a calculator. It might be a good idea. All right, so let's go and integrate this. If we add our 1 and divide, it becomes negative 1/3 x to the third plus 3/2 x squared. And we're going to evaluate that from 0 to 3. All right, so hopefully those are becoming pretty second nature for you by now, doing the integral there. We're then going to plug in the top limit and then minus the bottom limit. So it's going to be negative 1/3. And I like to put this whole thing in parentheses. More parentheses are better in my opinion. Negative 1/3 times 3 to the third plus 3/2 times 3 squared. That whole thing minus when we plug in 0, which is negative 1/3 times 0 cubed plus 3/2 times 0 squared. Fortunately, that's just going to give us 0 in this one because 0 times anything would give us 0. So we've got now 3 squared, or 3 cubed, should be able to do that in your head, is 27. So negative 27 thirds plus 3 times 3 is 9 times 3 is 27 halves. And then we got minus 0 over here. This is all goes to 0. All right, so you do have to do some fraction operations here without a calculator. Hopefully you can do this. You need to be able to do it on the AP exam. So our common denominator here needs to be sixths. Let's carry this up here. So we just need to multiply the first one by 2. That gives us negative 54 sixths. And then multiply the other one by 3, and that gives us 81. So plus 81 sixths. Then doing that would give us 27. So 27 sixths. And I'm guessing that's probably how they're going to want it. Since it is a non-calculator, simplest form of it. Actually, we could reduce that. We could reduce that to 9 halves, right? Yeah. Because 3 goes into both of those, 9 and then 2 times. All right, so yeah, this is going to be the version that they want. It does say in simplest form, no decimals. It's got to be a fraction in simplest form. So definitely doable by hand. Might take you some time. Check your work. Again, maybe submit it like this the first time without a calculator. And then if you get it wrong, go back and check it with a calculator the second time. So I'm going to go ahead and type that in. And let's go to another question. Oh, there's another little cool tool that it has on here. Not really helpful, but I thought it was just interesting. If you click on the like show solution or whatever example, it has this little slider thing. It's kind of neat. You can kind of see how it goes along here. If you watch the integral, it starts here at -1, and then it starts to fill up that area. Accumulation, you can see the accumulation over here. So I don't know, I thought it was kind of neat. But anyhow, let's go ahead and go back to the problem. I guess I just kind of showed you what the answer was, but that's okay. Let's go to this question. All right. So same deal here. We're going to be doing our top function minus our bottom. And once you get the hang of this, it's not terrible, I promise. It's just going to be the integral. We need to find our limits here. Our limits in this question, again, remember we want x values. Our intersection point here is at -1, and the intersection here is at 0. So it's going to be -1 to 0. Just make sure you always put your lower limit on the bottom, or else you'll end up with a wrong answer. The lower limit on the bottom, upper limit on the top. Our top function in this case will be this one. See, it's on top of the other one, and that's our f of x here. So that's -3x squared minus 5x, minus our g of x, which is, again, just actually a straight line here, -2x. So it'll be minus 2x dx. Let's go ahead and combine some like terms before we integrate. -3x squared, that becomes plus 2, so it would be a minus 3x dx. And let's go ahead and do our integration. Add 1 and divide. This becomes -3 over 3, so just -1 x to the third. And that becomes a minus 3/2 x squared, evaluated from -1 to 0. We then plug in the top. So that's going to give us all zeros, -0 cubed minus 3/2 times 0 squared, minus, careful with the signs here, very easy to mess up. negative goes on the outside, and then a negative 1 cubed minus 3/2 times negative 1 in parentheses squared. Again, our first thing gives us all zeros, so 0 minus. That'll end up giving us 4 negative symbols, so that would be a positive 1. Here we get a negative 3/2, I believe. Right? And then from there, down just a tad, we get 0 minus 1 minus 3/2. That will be a negative 1/2. So minus minus becomes a positive. So a positive 1/2 would be our answer. Again, if you need to check it on your calculator, do so. I'm going to go ahead and try that. Hopefully we did the math correct. We did see that it was 0.5. If you remember, we looked at that slider, so we should be good to go here. All right, let's see if I can get it one maybe just slightly different. All right, this one's got 2 a little bit more complicated functions, so that'll be good. Clear the screen. Okay. So same deal. We've got 2 parabolas. One's an upward facing parabola and one is a downward facing parabola. So we've got our first one, our second one, see our R there. Again, just make sure that the top function is the one you think it is. This one, they actually are, I believe, throwing you off here. Because if you just do f of x minus g of x on this one, notice this one is your top, right? The red is the top. Which function does that refer to? Well, that is actually g of x, right? Because that one is opening down. So that is our top function. I wasn't sure if they mixed it up for you in this or not, but I'm actually glad they did. All right, that is our top function because it opens down. This one is our bottom function because it opens up. It's the upward facing parabola. So in this case, we actually want to do g of x minus f of x. Those are just symbols we use, so make sure you're double checking that before you integrate. Our limits on this here is negative 1, and here is 0. So negative 1 to 0 again. Integral negative 1 to 0, top function minus bottom function. So negative 3x squared minus 6x minus 3x squared dx. If we combine some terms there before we integrate, we get negative 6x squared minus 6x dx. Okay. So hopefully that's clear why we switched up the order on that one. All right, let's go ahead and integrate here. When we do so, add 1 and divide, it will become negative 6 over 3, so negative 2x to the third. And then minus, that's going to be divided by 2, so minus 3x squared, negative 1 to 0. If you need to do that intermediate step, then do so. Just make sure you're not messing up. All right, so then we plug it in. We get negative 2 times 0 cubed minus 3 times 0 squared. That's all going to go to 0, so that's going to be easy. Minus negative 2, parenthesis, negative 1 cubed minus 3 times negative 1 squared. Close our parenthesis. Down a bit here. All right, our first part, like I said, is all zeros. Minus. Here, let's see, we get a negative 1 times negative 2 is a positive 2. And then this would become a positive 1 times 3, so it would be minus 3. 0 minus negative 1, so that becomes a positive 1. If you end up getting a negative area, that is bad. That means you messed up a sign or you put the limits in the wrong place. You should always get a positive area between two curves. All right, so hopefully we did that right. Let's go ahead and plug that in, see if we did it. Computation was pretty simple in that one. All right, very good. And let's do one more here where we have a constant. All right, so in this one, we're still going to do our top minus our bottom. They've actually got them in the wrong order in this one again, just to kind of throw you off. Our top function here is actually just this line. This line is a constant. It's a constant y equals 8, essentially what it is, or g of x equals 8, right? So that is our top, our g of x. Okay, our bottom the whole time, the underneath here, is our f of x, right? It's our bottom, top minus our bottom. So it's going to be g of x minus f of x. Our interval here, down just a tad. Our interval, where they intersect here, the x value, if we look down, is at -2. And here, where they intersect, is at 4. So it's going to be the integral from -2 to 4 of our top function, which is just a constant 8. 8 minus parentheses. This is where parentheses are important. The whole bottom function, x squared minus 2x, close parentheses, dx. Okay, so now let's go ahead, maybe just rewrite this before we integrate. Distribute that negative, it becomes 8 minus x squared plus 2x dx. If you want to further rearrange it, go ahead, that's fine. Let's go ahead and integrate. This becomes 8x minus 1/3 x cubed plus x squared. So cancels the 2. Evaluated from -2 to 4. This one might be a little bit more challenging for the computation. All right, so we've got first one, 8 times 4 minus 1/3 times 4 cubed plus 4 squared. Close that all up, minus 8 times -2 minus 1/3 times 2 cubed plus 2 squared. Sorry, these should all be -2s. Whoops. And this one, again, might be a little bit more challenging without a calculator. It is all doable math, though. So try your best without a calculator, then go back and check. 8 times 4 is 32, minus 4 cubed is 64. 64 times 1/3, 1/3 of 64. Let's just write it over. It's 4 over 3. Plus 16. All right, minus, this will become a -16, and that becomes -8. But we already have a negative in front of there, so that becomes a positive 8/3, right? Plus 4. I did that all correct. Yeah, should be good. All right. Now, even though these are separated by parentheses, it's okay to actually kind of group them together to redistribute. For instance, this thirds here, before I go ahead and convert these to thirds, I might actually want to just combine that with that one because it's already in thirds. So I'm going to group those together in just a second, kind of leave them as is for now. So I've got 32 plus 16, which is 48 minus 64 thirds. And then over here, I've got -16 and 4, which is -12. But I gonna get a plus, so it becomes a plus 12. And then this negative gets in here, which is a minus 8/3. So then if I combine my whole numbers, I get 60 and then minus 72/3. And fortunately, that one, I think it will give you a whole number, right? 72/3, that would be 24. So it becomes 64 minus 24. So we didn't have to worry about any common denominators there. And that would give us 40 if we did that all correct. Well, hold on. Yeah, sorry, that should be 60 minus 24, not 64. I don't know what happened there. 36, sorry. All right, sometimes talking and working doesn't work out so well. All right, 60 minus 24, yeah, 36. All right, let's give that a shot. Hopefully I didn't mess up anywhere on the math. And you would expect this to be a lot bigger area, right? Because we're going all the way up to 8 from -2 to +4. All right, it worked out. Good deal. Okay, so that is the idea, guys. Make sure you're taking your time on those. If you are struggling with this, make sure you do reach out to me, and best of luck.